Alrighty, so we want to find the lead coefficient and the degree of the polynomial. In order to do that, you first want to put this polynomial in standard form. So what we're going to do is we're going to start with the highest power, which would be right there. So it's negative 9x to the fifth. Then we want to go to the subsequent lower powers one by one. So the next one would be x to the fourth, so it would be a plus x to the fourth. Alright, then we have this minus x squared, and then lastly we have the plus 3x. So, but all you really care about when you are looking for the lead coefficient and degree is this first piece. The first piece is what you're looking at. Alright, and if you're trying to find the lead coefficient, you are talking about the number in front of that first piece. So my lead coefficient, I'll call my LC, is going to be negative 9. Alright, and then our next piece is what is the degree? Well, to get the degree, it's the highest power, so that power of that lead piece. So it is a fifth degree, so this would be a fifth degree polynomial. In order to make graphs of polynomial functions, you need to know the end behavior. So we're going to find the end behavior of these two functions. Now, with this particular function right here, to find the end behavior, the two things you need is to know its degree and the sign of its lead coefficient. So let's start with the sign of its lead coefficient. Well, when it's in factored form, the lead coefficient is right in front, that number. So that number right there in front. Well, that number right there in front is a negative 2. Now, what's the sign of that? That would be negative. So we call the lead coefficient A here, so I'm going to call it negative. Now my degree is a little bit trickier. For my degree, you have to look at each of these factors and multiply this all out, and then when you multiply that out, you look for the highest power in that. Now that would be a nightmare if you actually really have to do that. So we want to think of a shortcut. Well, if we multiply this x minus 4 times itself, that would give you an x squared. And if you take that x squared times another x to the third, and then if you multiply that x to the third power piece, polynomial, times another x to the fourth, and another x, that would be x to the fifth, and another x, that would be x to the sixth. So what we find out here is this is a sixth degree polynomial, which 6 is an even degree, and that even is going to be important. Alright, so now that we know that, what we know about this graph is by the a value, that's saying negative means as you go to the right, as you go this way, it's going to be dropping. It's got a negative trend. You're multiplying by negative numbers, so it's going to be going down as you go to the right. So I draw a little picture and say it's going to be dropping on the right as it goes to the right. But the question is, what's it going to do on the other side? Is it going to be going up, or is it going to be going down for this polynomial? And that deals with its even degree. If it's an even degree, it's going to go the same direction as the right side. So since the right side is going down, so will the left. Now, if this was an odd degree, like 5 or 7, it would be going the opposite for degree, opposite direction. So evens go the same direction as the right side, but odds go the opposite direction. So let's see what this one says. This one's a little bit easier because it's in standard form. So the lead coefficient is right here in front. So there's our lead coefficient. And our degree is right there as the highest power. So this is our a value is a positive, and our degree is a 7th degree, which a 7th degree means it is odd. So that is an odd degree. Okay, with that said, we look at the a is positive, so that means on the right side you're going to be going up. Because if I think something's multiplying by a positive number, it's just going to be going up, 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 up. If you get positive numbers multiplied by positive numbers, it just keeps growing. So it's going up. But since it's odd, on the left side, we're not going to go up because odd is opposite. So on the left side, you are going to be going down. So this function will go up on the right and down on the left. This up one, this one right here again, goes down on the right and down on the left. So it's a little bit harder because finding the degree is a little bit trickier in this than it is in standard form. Alrighty, let's look at this graph right here and answer these 4 questions. The first one, we're basically looking for the interval for which it is increasing. But we only want one approximate interval. Well, I'm going to put all of them just in case we see them, and then when you on the test, just write one of them. So we have to look, where is this increasing? So as you go on this graph from left to right, you are dropping here. So you drop, 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 drop. But then right here, it's going to start going up. That's called increasing. So this little part right here, we would call that increasing. So we're increasing right along that. Okay, then right here, oh, we're dropping again, dropping. It's called decreasing. And then from here, this minimum, we're going to go up again. This is called increasing. So we're increasing from here to here. So let's highlight that as well. So you're going to be going from there all the way up. That also would be increasing. And then we are dropping here on. So this interval and this interval is increasing. The question is, how do we write that interval? When we write intervals, we look at the x-axis. So if we look from here to here, let me mark those a little bit better. So we're going from here to here. We're going from here to here. So if we think about that, well, what we're doing here is we're going from this to this. So if you look at the x-axis, we're going from a negative 2x to a 0x. So a negative 2 to 0 is our interval for which this yellow part exists. And our intervals are on the x-axis. So we're between negative 2 and 0. And we're going to write that as an interval like this. So it's negative 2 to 0. I know it looks like a coordinate, but it's not. You can also write it like this. X is between negative 2 and 0. So you can write either notation you want. So the next one is this one. So from here to here, well, this one starts at, looks like 2, and it goes until, looks like 5. That's right there, 5. So 2 to 5, it would be increasing. So let's write that out. That would be from interval 2 to 5, which could also be written, x is between 2 and 5. Either notation is fine. Just put one of those on the test. Quiz, sorry. What is the approximate x value for the local maximum? So we're looking for maximums here. So local maximums. You call them local maximums, relative maximums. But we're basically on this one looking for the hills. So we look for any hills, and it looks like there's 2 of them. Now we don't want the coordinate of that hill. We want the x value. So you got to be careful here. We want the x value of that. So for this coordinate, our x value is, for this coordinate right here, our x value is 0. It's really 0, negative 2. And for this one, it looks like it's 5, like 5 point something. But our, so this one would be x value 5. So our maximums are at 0 and at 5. So we just simply put x equals 0 and 5. But for your quiz, be careful, you want one of them. So choose one of those 2 where your maxes would be. Now if we want minimums, it would be at 2 or negative 2 if we were looking for minimums. Next, what is the sign of the lead coefficient? So be careful, all we want is the sign of the lead coefficient, sign of the lead coefficient. So to get that, we look just simply right here at the edge. At the end on the right side, if we look at the right side, what's happening? Is this edge going up or down? And since it's going down, that means it's dropping, so it has kind of like a negative trend. So what is the sign of it? A, which is our lead coefficient, is a negative for that because it's dropping. If it was going up, it would be a positive lead coefficient. Lastly, what is one possible degree for this function? Well, to do that, what we now want to do is we want to look at the other side and compare them. Do you see how this one's going down and this one's going up? Since they're going opposite directions, that tells us right away this is an odd degree. All right, so it's an odd degree function because they go opposites. If they went the same direction, let's say if they both went up on both sides, that would be an even degree. Now, next, we want to think, okay, so what odd number would it be? Is it any odd number? Well, basically, you look at the maxes and mins as one option. There are different options to look at, but we look at the maxes and mins for this situation. So we have 1, 2, 3, 4 maxes and mins all together. Because of those turnarounds, what that means is it has to be an odd number that's 4 or bigger. Since 4 is not odd, our next one would be 5. So a possible degree would be a 5th degree. And then you could have a 7th degree, which is the next odd. You could have a 9th degree, and ... So any of those are possible. We know it has to be odd, and we know by the maxes and mins it can't be less than 4, but it could be more than that, but it can't be less than that. So these are possibilities. So just choose one of those. Alrighty, for this one, I want to write a 5th degree polynomial that has the following zeros. So it's probably going to be in factored form. That just makes it easier. And to make a polynomial, you first have to make an equation. So we want a polynomial equation here. So this would be f of x equals, all right, so we want an equation. Let's see. What we have here, let's take this one first, this -5. If that's my 0, well, a factor that would create that 0 would be x plus 5. Now, again, why would that create a 0 of -5? Well, if you put -5 into this, don't you get 0 out? That's why it's called a 0. Oh, okay. So to get a -5, you need this factor because it creates a 0. Okay, so now let's look at this. Let's look at the 6 here. 6, but what does multiplicity of 2 mean? Well, what this means is I get 6 as a 0 twice. So I got 6 as a 0 twice. So what does that mean? Well, to get 6, it would be x minus 6. Because if I put 6 into x minus 6, I get 0. Well, with the multiplicity of 2 means I have this twice. So I can write it twice, but couldn't I just also just put a squared? Instead of writing x minus 6, I can just put a square. All right, and then now for -7, so what would make -7 0? So let's put this last 0 as a factor. Wouldn't that be x plus 7? Because if I put -7 into this, won't that become a 0? And with the multiplicity of 2, that means I have 2 of those. So how do you write 2 of those? Well, I'd put squared instead of writing x plus 7 twice. So that would be a possible 5th degree polynomial with those specific zeros. Now, you could put any a value in front you want, because all that would do is stretch it vertically or flip it or just change its kind of how high or low the maxes and mins go or flip the in behavior. But this is one specific possible polynomial. Alrighty, we're going to find the zeros for this and then sketch it right here. So the zeros are what makes these factors 0. So we look at each one of these and we think what makes each piece equal to 0. All right, so what makes this equal to 0? Hopefully, if you solved it, you can see it's x equals 3. So 3 would make the first piece 0. So what makes this equal to 0? Hopefully, you can see it's -1. All righty, and what makes x plus 5 equal to 0? Hopefully, you can see that would be -5. So this makes that 0, this makes that 0, and this makes that 0. So those are my zeros. All right, so let's list those out. My zeros are x equals 3, -1, and -5. Now, do you see how 3 has a squared on there? It means I have 2 of these. So let's mark that. There's something unique about that. So 3, I'm going to put a line underneath. 3 has something special about that 0 because there's 3 twice. So we're going to think about that. But next, for graphing it, by the way, this are the zeros. So for graphing, we have to figure out the in behavior and plot those zeros. So let's plot the zeros first. So we have +3 is right there, -1 is right there, and then -5 is -2, -3, -4, -5. Looks like it's right there. So we have those pieces. Next, we got to find our in behavior. Well, we have a positive in front. So since my a value is positive, all right, that means on the right side over here, it's going to be going up. So I know the right side is going to go up over here. All righty, but we need to find our degree now. To find our degree, well, we have an x here, 2 of them because it times itself, so that'd be x times x is x squared. times another x is x to the third, times another x will be x to the fourth. So this looks like it's going to be a fourth degree, and a fourth degree is an even number. So an even means that since we're going up over here, it's going to go the same direction on the other side. So on the other side, it's also going to be going up. So on this side, we're also going to be going up. So we kind of know the edges of this. We're going up on both sides. So now we have to go through these dots and work our way to make a graph. But this 3 is going to do something unique. All right, this 3, what is this 3 going to do? Well, that 3 means you're going to reflect off that 0. So here we go. It's going to come down here and reflect off the 0 there. Okay, and bounce off. All right, and then, well, that's the only one with a multiplicity or a multiple. So that's the only one that's going to bounce off. The rest, it just goes straight through. So for all the other zeros, this is going to turn back around. It's going to go straight through. For all the other zeros, it just simply goes straight through. And then we have our sketch. Going up on both sides, touching those zeros or going through. Again, this was just a bounce off because it was a multiplicity. And there is a quick little sketch. The 3, what that does is stretches it. So that tells us kind of like how high or low these hills and valleys would be. But we're not going to pay attention to that. We're just sketching it.